Okay, so matrix multiplication. This looks really complicated, I know, but basically it's when you take two matrices and you're multiplying them together. So let's say I have something like 1, 2, 3, 4, 5, 6. I'm being really creative. You don't have to write this down. But I'm going to multiply it by 7, 8, 9, 10, 11, 12. Are those the same dimensions as each other? They are not. Okay, this is what? This has 2 rows and 3 columns. It is a 2 by 3. This has 3 rows and 2 columns, so it's a 3 by 2. Now, if I was trying to add these or subtract these, that would not be possible. Okay, but when you're multiplying matrices, this is actually the sort of thing that needs to happen. One of the things that's telling me up here in all this about doing this multiplication is the first thing you do is you look at these dimensions. So it is the number of columns of the first matrix and the number of rows of the second matrix. So order does matter here, by the way. But notice that those numbers are the same. That has to be the case. In order to multiply these together, those have to be the same. The other parts, this part here, this 2 here, and this 2 here, if you take those two numbers, that actually tells me the dimensions of my answer. My answer is going to be a 2 by 2. Okay? And so I know it's going to seem really confusing to begin with because you're going to be like, what in the world? Why is that? Well, it has to do with the way matrix multiplication works. The way matrix multiplication works is you're not just multiplying like corresponding elements. That's not what matrix multiplication is. Matrix multiplication is where you're taking a group of numbers and multiplying it by another group of numbers in the other matrix. It always has to do with a row in the first matrix. So there are only 2 rows in the first matrix, right? That's where this 2 comes into play. There's a row with 1, 2, 3, and a row with 4, 5, 6. So you're taking a row and you're multiplying it by a column in the second matrix. So there are 3 elements in this row. There are 3 elements in this column. This is row 1. This is column 1. The answer that I'm going to get is going to go right here because this is row 1, column 1 of my answer matrix. Okay? So if you're wondering, like, where does my answer go? I mean, there's a pattern to it that you're going to see, but technically you could figure out based off what row and what column you multiply together, that tells you where the answer is going to go. And you are multiplying, but you're multiplying and adding. So you're taking corresponding elements. So when I'm doing this row, the first element is a 1. The first element of this column is a 7. So that is what you're going to multiply together. You're going to take 1 times 7. What's 1 times 7? It is 7. All right? Then you're going to go to the second element. The second element of this row and the second element of this column are 2 and 9. So you're going to take 2 and 9 and multiply them together. What's 2 times 9? 18. Then you've got the third element of your row and the third element of your column, and you're going to multiply them together. So 3 times 11 is 33. So you're doing, since there's 3 elements in this row, you're going to be doing 3 products. And then you're going to add those answers together. So this comes out to be 58. That is what goes right here. So then I'm going to repeat that process with the same row. So I'm still doing row 1, but there's another column I can multiply that by. That's row 1, but this is column 2. So that's going to go in this spot, row 1, column 2. So I'm repeating that process. I'm going to take the first element times the first element. So 1 times 8 is 8. 2 times 10 is 20. And 3 times 12 is 36. I didn't write out as much there, but that's the 3 products I get. Add those together. I got 28 and 36. That's what, 64, I think. And I would get that value right there. I have multiplied this row by both columns. There's nothing, no other columns to multiply by over there, is there? So now I would start with this row. This is row 2. This is how I'm going to get my answers in row 2 here. So I'm going to repeat that process. Take this row times this column. Again, first element times first element. 4 times 7 is 28. Second element times second element. 5 times 9 is 45. Third element times third element, that's 66. So I add that together. Let's see, 66 and 45 is 111. So plus 28 would be 139, I think. And that would give me that element. So that is row 1. I'm sorry, that's row 2, column 1. I multiplied row 2 and column 1 to get that answer. It's going to take some practice. Take this same row, row 2. I have not multiplied it by this column yet. Row 2, column 2 happens to be the element I'm missing here. Okay? So, take this row times this column. So 4 times 8, 32. 5 times 10, 50. 6 times 12, 72. So that's 104, 154. Now, I took a 2 by 3 times a 3 by 2 and got a 2 by 2 for an answer. If you were to flip these around, you'd have a 3 by 2 times a 2 by 3. You would not get the same answer because the inner dimensions would be the same. They'd both be a 2 this time, but the outer dimensions would now be the 3's. The answer would actually be a 3 by 3. So there is no commutative property of matrices when you're multiplying. You know, like you could take 7 times 8 and 8 times 7, and with regular multiplication, 7 times 8 and 8 times 7, they're both 56. You get the same answer either way. Matrices do not work that way. As a matter of fact, it might not even be possible. I could take like here 1, 2, 3, 4, 5, 6, again being really creative, and then have 7, 8, 9, 10, 11, 12. Same elements I just had, right? This is a 2 by 3, this is a 2 by 3. These inner dimensions have to be the same. Are they the same? They are not the same. So this is not possible. So not all multiplication problems are even possible when it comes to matrices. Okay? All right, so I will give you a minute. Go ahead and try, see if you can do example number 3. I'll pause here and come back to this. Give you a minute.